Hello students, welcome to second lecture of physics. In this presentation you will learn about a huge topic, that is mechanics. So before we start, let us know what is it. It is the study regarding with the motion of object. Which kind of object? Only macro object, means those objects which are almost bigger in size. We study the cause of motion and the responsibility for the cause. Means if a force is changing the object position, then why the force is doing so? In this we will learn it, and the change in the object like displacement, speed, acceleration, these things we'll learn. And the fourth point is basic physical unit to be developed for the study of forces and torque. Okay, so let us brief outlook of this course, mechanics. Here you can see mechanics have so many topics, some small, some big. So from where we are going to start? We will start from physical units. Then thereafter we'll study vector operations, and after vector operation we'll study motion. In motion, velocity and acceleration. Newton laws, mass and forces, gravity. We'll discuss one topic later on. So now starting from units and measurement. So what is the unit and why we are measuring it? Suppose we wanna compare two things, a goat and an elephant. So which one is bigger? We all know elephant. Which one is smaller? Goat. But when we talk about by how much it is bigger, then we need the unit. Okay, unit and measurement. So all mechanical quantities can be expressed in terms of these three quantities, that is mass, length and time. These three quantities are basic quantities, and with the help of them we can write any physical quantity. For example, we have a mass of 10 kg and we have a mass of 20 kg. So both masses have the same unit, but their number is different. It means 10 and 20 means 20 times kg and 10 times of kg. There is a big difference, almost a difference of 10 units. So now the question arises, who decide these units? How is the standard unit chosen for the physical quantity? The first thing is that it should have international acceptance. Means the system that we are describing, it must be understood by everyone. It must have the feel that everyone can understand it. So the system defined here are called as SI units. It is internationally accepted. Okay, are you getting it? Now if the units for these quantities in any consistent set of units are denoted by m, l and t, means any quantity that containing mass as well as length as well as time, so we will denote it by m, capital M, L, T. Now how to do it we will discuss later, but now this thing you should be knowing. Now there are two types of quantities. The first one is fundamental and the second one is derived quantity. Now what are the fundamental quantities? Write down the definition in your note copy so that it will be easier for you to revise it. What are fundamental quantities? The fundamental quantities should be independent of each other, and the secondary, all the quantity may be expressed in the term of fundamental quantities. Suppose that we have length, you know the unit of length is meter, and now the secondary thing is we want to calculate area. So area is what? Multiplication of length, means L square, or we can say it becomes meter square. So this meter square is dependent on L, length. Let us take another example of speed. Okay, let me write it down. Speed is equal to distance upon time. Distance upon time. So distance and time, these are two quantities, but speed is dependent on these two. Speed is dependent on these two quantities. So distance, the unit of distance is meter, we all know, and unit of time is second, but the speed becomes meter per second. So unit of speed is meter per second. Now the question is, how do we know which one is fundamental and which one is derived? So fundamental quantity means independent of any other quantity, like distance is meter, time is second, so these both quantities are fundamental, and derived quantity is speed. Now we have 7 type of fundamental quantities. How many? 7 types of fundamental quantity. So I'm taking the name: length, meter; mass, kg; time, second; electric current, ampere; thermodynamic temperature, that you call simply temperature, that is in Kelvin; amount of substance, you know about it, the amount is calculated in mole, amount of substance; and one more thing, luminous intensity, that is calculated in candela. There are 7 physical quantity, and all other quantities that can be derived by using these quantity. So I'm taking some more example so that it will be clear to you. So let us take the example of force equal to mass into acceleration, and the unit of mass is kg, acceleration meter per second square, so the unit becomes kg meter per second square, and we often called it as Newton. Now what about acceleration? Acceleration equals velocity divided by time. So the unit of velocity meter per second, and when meter per second divided by second, it becomes meter per second square. Okay, now we have a series of these unit. The relation you can see here, okay, the chain of mechanical quantities. Now this chain works as when length is divided by time, this equals velocity, and when this velocity divided by time, this equals acceleration. I have explained. And when this acceleration into mass becomes force, explained. And when force is multiplied with length, or simply you can say displacement, force into displacement becomes work. And when we have work, it is same as energy. And when work divided by time, what we get? Power. Means all the quantities are related, but the fundamental basic quantity is starting from length then time. These two quantities are playing massive role, and then thereafter sometime you got mass also. Means these three quantities are able to explain like energy, force, work. Understood? Now if we want to formulate it in dimensional formula, so let us understand the basic meaning so that we can easily do it. Here we go. Length is denoted by capital L. Mass is denoted by capital M, and time is denoted by capital T. This is the representation for representing dimensional formula. So let us see. Length is denoted by L, and when you divide length by time becomes L by T. This one is the dimensional formula of speed. Again, same for the velocity. If you studied it class 9th, hopefully, yes, you have done it. And thereafter velocity, the rate of change of velocity is acceleration. Now L by T square means you are dividing one more times by time, then it becomes L by T square. And when you multiply with it mass, as you multiply it with mass, you will get force. So the quantity of force, look here, acceleration is L by T square, and as you multiply this acceleration with m means mass, you get ml upon T square. And now same, this one is for the torque, means you are multiplying one more time with length, that is the arm known as, we'll discuss later how this torque and force are related. But now we have to care about this thing, okay, this thing. And then thereafter when it comes to work, means force into displacement. Now the dimensional formula torque and work are same. So is it possible? Yes, of course. It is possible that different quantity have same dimensional formula. Now from work and energy, both are same almost, and for the power we will divide it one more time by T, so ml square by T cube. Understood? I think now the concept of dimensional formula has been cleared. And now we have a chart of basic mechanical units. In bracket their dimensional formula are written: length, time, mass, velocity, acceleration, okay, force, work, energy, power. You have studied it. And now their SI unit, CGS unit and US common. Means every region, every country has some, due to the less collaboration, they was measuring in some different unit, and then thereafter a system is made for the units, so that a unit can be accepted internationally. The system called as CGPM. It stands for General Conference on Weight and Measure. So this system gives the SI unit, but CGS unit is also important, and US common is one of them. So I'm telling you this because everything is changing: meter, centimeter, foot, but the dimensional formula L remains same, and same for the time, same for the mass, velocity, L upon T, but it is meter per second, centimeter per second and foot per second. So these units are changing, but their dimensional formula remains same. So dimensional formula is the powerful tool, no matter we are working in which quantity, MKS or CGS, no matter, their dimensional formula are same. So a lot of significance of this dimensional formula, and we will learn it in the dimensional analysis. Okay, now your homework is, you have learned about dimensions. You have learned about dimensions. So I'm giving you homework problem from your book. Find the dimensional formula from your book. Okay, now we shall stop here. We'll come in next presentation with the new topic, dimensional analysis. So see you in the next lecture.